Hello folks, Karthik here, product marketing. Back to product marketing. I want to start with a very uplifting case study, as you will see. Jason talked about controller. So this is a case study on our controller product and controller and data plane. So Data Posset, they are a solution provider, IT systems integrator that they manage the Kenya's national health information systems infrastructure. This Ministry of Health basically spearheads the effort for addressing their HIV/AIDS problem across the country, right? One of the applications that is used by literally everybody, I mean, it's open to the public, so everybody accesses this application to basically, it's a testing program for to test their national viral load early infant detection program. And the stack they were using was a WAMP stack, Windows, Apache, MySQL, PHP. As I mentioned, literally at some point, everybody in the nation started accessing. So the application itself, it would collect data, health-related data. Then there's another application that would actually analyze the data, and then there's a portal where all of these results get published. They disseminate and report all the information, right? And they were adding a lot more features to the web front end, and again, a lot of people started accessing the application. The WAMP stack just couldn't handle resource exhaustion. 90%. One of the big advantages of NGINX Plus, the data plane is delivering really high performance. Yes, we know that, but extremely efficient resource consumption, right? So what was happening was, again, connections would get dropped. So they started using NGINX Plus. They, by the way, also had traditional load balancers, hardware-based load balancers. So, Rob talked about plethora of tools. They were using both Apache and a hardware load balancer. They used this opportunity to basically revisit their sort of architecture and think about, okay, we should probably embrace the cloud. Starting off with a private cloud, vCloud, started using NGINX Plus, and they were able to literally move to the cloud, right? Because again, with the hardware, you can't move to the cloud. Of course, all the performance issues were resolved. The controller came in very handy when it came to troubleshooting. For example, one of their upstream servers was down with NGINX. So the controller was able to point that out. NGINX Plus has another capability, sort of on-the-fly reconfiguration, adding a new upstream server on the fly without actually what we call without any downtime, right? So controller helped them identify a problem, and they were able to fix it literally in zero downtime. So we literally saved lives. Questions on? Okay, so now I'm going to switch to API management, the API management use case. So I want to just start off with what API management is. I think some of you may be familiar with it. Entails all of these elements, starting off with defining and publishing APIs. So define APIs, you ideally want to be able to just define it once and publish it to various different environments. Well, publish it to the gateway, but also you may have a dev environment, you may have a production environment. So to be able to simplify that process. Security is a key aspect. What do I mean by security? Starting off with your API consumers, API clients, authorizing, authenticating those clients. Are they really who they say they are? Do they have access to specific API resources? You're mitigating DDoS attacks against your endpoint. Somebody, you're not just having a DDoS attack by having a lot of API calls. And then also, of course, securing the backend that's actually processing all the API. Generating results for an API call, right? So that's what security entails. And of course, traffic management itself, traffic management, traffic mediation, that's where the API gateway comes in, routing the API calls to the right backend to ensure that the results, the responses are valid. Then once you've sort of the first three elements are along the lines of, you're setting up your APIs and API infrastructure. After you've done that, you need to, especially for NetOps, INO folks, they would be interested in monitoring aspects. When am I seeing errors? which APIs are actually resulting in a lot of errors, right? Those kinds of use cases and questions that these guys would be interested in. Then there's analytics. So in the API world, especially over the last few years, there's a new role, API product manager. This person just, this person is responsible for making sure that the APIs that an enterprise has, it meets the requirements of the consumers. And the consumers could be their own customers, they could be partners, developers, other third-party developers. Is the API really working for them? And also making sure that the enterprise, it serves the business needs of the enterprise, right? So, which APIs are used most, which APIs are used least? How's API traffic trending over time, right? Just sort of more business-related aspects of API consumption, that's where analytics comes in. So that's another key element of API management. And then finally, you have the dev portal, which you guys, again, probably are very familiar. Onboard API, third-party developers to onboard developers very quickly, publish a catalog of APIs, documentation, sample code, all of those elements, right? So I just wanted to sort of set the stage for what API management does. I think, again, you guys may be familiar with it. Questions on this? Okay. So now coming to what NGINX API controller, NGINX controller API management module. So as Rob was saying, think of it again as an easy button that allows you to perform all the API management lifecycle, to be able to define, manage traffic, secure, monitor, troubleshoot, all of those across a multi-cloud environment. Just like in the load balancing world, you can have your controller, any environment, bare metal, VM, public cloud, private cloud. The gateways can be across any environment, especially in the case of a multi-cloud world, hybrid cloud environment. It's very useful. And of course, all of the metrics that Jason talked about, they can be extracted via REST API and integrated with a bunch of these tools, right? At a high level, that's sort of and Kevin will go through the demo, but this is what controller does. Questions?
The NGINX Plus piece, that's the standard load balancer.
That's the data plane, correct.
And from the NGINX controller, you're just pushing certain configuration down that to turn that into an API gateway and configure it how is set up in the controller.
Correct. And you'll see in the demo, you can define APIs. As you push the configuration, you're optimizing the data plane to be as a gateway. You can set rate limits. You can have JOT authentication, all of those.
So your API management product is a combination of the controller and NGINX Plus?
Correct.
Okay.
Correct.
And where does the dev portal live? Is that on where the controller is running?
Dev portal, we don't have it yet. It's on the roadmap, but it will be part of the controller.
So how do you onboard developers into this platform without a dev portal?
So right now, it's a great question. There are two main use cases for where we think API management would be a great fit. First is microservices. So in an organization that's looking at microservices, they want to, for internal APIs, there's just a lot of APIs, and they need to be able to, microservices, of course, APIs are the ways they communicate amongst each other, right? The traditional API management solutions, I'll go over that in more detail in the next slide, actually. They were built, as Rob was saying, to manage mainly what I call north-south traffic in a world where they had, VMs and not even VMs, actual servers, right? Not in the container world, not to handle east-west traffic. So our first sort of sweet spot would be sort of this internal APIs, either for microservices or just facilitating collaboration between various departments within an enterprise. So where I'm going with this is, yes, even for internal APIs, you need to be able to, the dev portal is critical, but at least it's somewhat of a secondary concern than when you're actually publishing external APIs to be consumed by third-party developers, right? Again, it's definitely in the roadmap second half of this year. We wanted to sort of introduce the table stake functionality of, if I go back here, we have all of these elements, 1, 2, 3, 4 in our current product. The last two will be we're going to be rolling out soon. Does that answer your question?
Yeah.
So I think it's a somewhat of a good segue. You guys are familiar with, we talked about this slide. So, we are open source. Rob talked about some of the metrics. Because we are open source, we are the underlying data plane for, a variety of API management solutions, as you see here, right? It's a great data point that I want to share. But so what's unique about our solution? There's a lot of API management vendors, as you guys probably know, and many of them are users. We believe we are very pervasive precisely because of this reason, as an API gateway as well, right? So what's unique about us, right? What's unique is what we believe is unique is our new architectural approach to API management. What we have done is actually decouple the data plane from the control plane. So what do I mean by that? When you're processing an API call, all of the other solutions that we saw here, and if you remember the API lifecycle management, right? The API call has to go through not just the data plane, but the control plane that does the API definition, that manages security, that handles the monitoring. These are very tightly coupled, and there are various layers between, the configuration information has to be stored in a database. There is rate limiting that also needs to be stored somewhere sort of, again, tied to the control plane. What we have done is actually decouple processing an API from the data plane from the control plane when you need to process an API call. So what I mean by that is, again, when you need to, all the configuration information is handled in runtime, in memory rather, because of NGINX's architecture, core architecture, extreme, being able to use resources very efficiently. The configuration information is stored in memory that allows it to allows for a decoupled architecture, right? There's no connection from the gateway back to the controller just to be able to process a call. That means you get very high performance, same performance, whether it's north, south, or east, west. And again, I go back to many vendors that were even launched 4 or 5 years back in the age of when there was no east-west traffic. There's some of the vendors are introducing what's called micro gateways just to be able to handle east-west traffic. You don't need that. Of course, you can deploy NGINX Plus. It can be on a floppy disk, so it's very small footprint, less than 2 MB, easy to deploy, and reduces complexity, right? So that's the sort of a key differentiator to the point earlier about, yes, we don't have a dev portal yet, but we do believe, consistent with our philosophy of delivering high performance, very resource efficient, that plays well, especially in this age of microservices. Right?
Given that you're saying something like Kong is using NGINX, does it suffer from these problems that you're fixing, or?
Yes. This is what I call anatomy of just, again, mediating an API call, right? Kong literally is built on, Kong and other folks, it uses NGINX as a core. Then they have databases to store some of the configuration information, rate limiting information, and then they also have plugins and scripts, especially Kong. You talked about Kong. They have a plugin for rate limiting. They have a plugin for authentication. That all adds overhead, basically. It's literally like this, right? And to be able to just process a call with us, it's just you remove those limits.
Okay, I'm not sure I understand. Just because they're adding a plugin, that makes it inefficient. I mean, it's just turning something on within the code, I guess.
Well, so you are just to be able to again process a call, you're adding more latency to be able to, it has to look up something in the database, some configuration information or rate limiting information. The footprint of the the API management solution itself is larger because of these.
So with Kong, you're saying, or these competing products, you're saying every API call that the data plane that's running that API gateway, every call has to make a lookup to the control plane to its database to get and be able to make that.
Right, and I'm using control plane here, to refer to the database, to refer to these additional elements that are
consider
tied.
that still part of the data plane.
So
If we want to get into the semantics of it, the control plane is the portion that applies configuration. It's not the configuration that's running currently. That's more what's happening on the data plane.
right.
That's what I'm saying. When every API call doesn't have
How is
to go through
NGINX
that.
handling something like an authentication plugin via your model that's more efficient than Kong's plugin for authentication?
So authentication, for example, natively we handle JOT authentication, NGINX Plus, OpenID based authentication interfaces as well. Rate limiting, again, we have a key value store where it's again handled in memory versus, well, let's take Kong again. They have a Cassandra database, Redis database.
Redis database would be in memory.
Okay, so what we've heard from customers is it does add these additional databases that they have to install.
Are these specialized components that are only available in the premium or plus edition of NGINX, and that's why it doesn't exist in the Kong product?
Yeah.
Because they don't have access to those levers?
Yeah, so the big difference with like a Kong or someone like that is, the big difference with Kong or someone like that is, so they're technically Open RESTy, which is a variant, and so they're using Lua code, and so each time they go to process one of those, it has to go up through the Lua code and back, and so that's where they're getting a lot of latency. So their JOT authentication or their rate limiting is going through all that extra. Semantics aside, whether it's in the data plane or control plane, it's going through extra code to process that call. The way we do it is would be a native file, a native policy pushed to our config, and so it would just go right through without having to go up and down any kind of additional elements of the stack.
Okay. All right.
So that's the big thing. So it's our testing shows it's about 3 times faster, depending on the API call and volume. So there is a big latency element that goes through having to process all that extra Lua code.
Yeah, so we do a clustered approach. So all of the state is being shared amongst the NGINX cluster, and those are being stored in memory. So if one particular NGINX node goes down, it's still just referencing that internally in memory. And processing, it's independent. So if you have 10 NGINX servers and 5 go down, those 5 are still operating on their own, right? Okay. There's no dependency on some kind of cluster or something like that.
Okay.
Yes.
How do you manage the API templates? And in the other side, the token services in your APIM?
So the first question was, how do you manage API configs? Is that right?
Pardon?
API templates, I think she said.
Because in best practice, you create some template for your API.
Right.
And so how do you manage the template in order to deploy some other API? And how do you manage also the token services?
Okay, first question, I got your first question. The templates are for load balancing. Kevin will go through a demo. For APIs, you can define it and you can create separate environments, dev, production. So you define it once and then you just push it to various environments. We still don't have versioning of APIs. That's not there yet. Okay, that's in the roadmap, but we don't have it yet. But at least you can create different environments and reuse that same APIs that you have defined for, again, dev and test, or you can create separate versions.
Yes, but as you've got a cluster approach, do you have a unique repo for your templates? Do you manage that or not?
Yeah, at this point, we don't have templates or versioning for APIs. The API piece that's coming, right, Kevin?
Yeah, so right now, all the configuration for API management is done through the UI, which I'm going to show so you guys can see. But there's no versioning or there's no API documentation or publishing or anything like that yet. It's a rather new module that we added to controller, so it's somewhat early right now.
What was the second question? Sorry.
How do you manage a token service, the STS?
The what service? The
Token services, because which is API, we should have to give a token.
Yes, got it. Yes. So we support API tokens. He's going to show you can actually create tokens from API management module controller, and you can share those tokens, and we can authenticate using those tokens. We also just JAWT authentication as well.
Okay, is that an OAuth or can you plug it with an Active Directory or something else, or LDAP?
We can't do Active Directory today. There's no integration. But that's also on the roadmap.
Right, thanks.
So we launched the controller management module only in January, so it's been 3 months.
So do you have any kind of policy management for APIs? So, I based on where the traffic comes from or the client, I want to point it to X function or X container or so on and so forth. I want to build a full policy framework around my API.
I'm going to do a demo showing you the policy stuff, so that'll be in there.
You can create policies.
Yeah, I mean,
various environments, as I call it.
Yeah, briefly, we allow you to create policies based off of like requests per second, like actually limiting the amount of requests going to an API. We support API policies for API key that we can manage the key. We also support JSON web token as well. So I'm going to show all that for you guys.
Okay.